Give a few minutes for people to filter in, just making sure that have this all set up. This is kind of our first run of doing this weekly update, answer questions, kind of let everyone know what's going on and how the Wefunder is going, and then get to be able to answer any kind of big or interesting questions that people who are looking at investing us have to ask. Yeah, give a few more minutes for people to trickle in. Probably just gonna spend a bit of time kind of giving a bit of background on Accelerate 3D, what we're doing, what we're building, our vision for the future, introduce us a little bit, our background, all of that stuff, update everyone on how things have been going, how the campaign is going, company updates, things like that, and then start diving into the questions. We'll probably start with ones that have already been submitted onto the page, as well as some common ones that we get on a pretty regular basis, whether in person or online in other ways, and then start answering questions that y'all have. That y'all feel free to put them in the Q&A tab. Good place to throw in stuff as we go, and we'll be able to see those and get to those as we go. Let's see, 10:02, probably give it a little bit more. Sabine, you doing good this morning?
Yeah, with my beautiful kombucha.
Sponsored?
Sponsored, yeah.
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 Gotta get that.
Product placement.
Product placement. Yeah. We can start putting those in the machines.
I was only paid for one, so.
Oh, there we go. Yeah, that's all they got. That's all they got. All right. Another little bit. All right. That's probably good. Anyone shows up late, it's their fault. They get to miss out on the awesome stuff. Yeah, so figure I'll give a quick overview of what we're doing, what we're building. So basically at Accelerate 3D, our whole thing is that we are helping companies that are building larger size pieces of equipment like robots, planes, aerospace, oil and gas, to be able to get larger size polymer parts produced quickly and cost effectively. Because being able to quickly and cost effectively produce these larger size, high strength polymer parts will be a total game changer for both manufacturing and supply chains. Really quick overview of the team real fast. We'll go in a bit deeper into myself and Sabine here in a minute, but my background is mechanical engineering, and I also hold the patent on our new high-speed 3D printer design, which was issued on Star Wars Day, so that was fun. I like throwing that one there. Sabine here, our COO and co-founder, her background is material science and polymers, and then our CTO, Matt, his background is a senior level software engineer and has worked for companies like HP and Digital Pharmacy and a whole bunch of other impressive ones. So the best example of both what we do and what I mean when saying larger size machines is that we were able to print the entire frame and structure of a nearly 5 foot tall autonomous cleaning robot in a quarter of the time and for a quarter of the cost compared to all other quoted options. And we did this on our technology demonstrator proof of concept prototype that was never actually intended to run print jobs for customers. See, when we initially started off, our plan was to sell large size, multi-$100,000 machines. But the more customers we talked to, the more we realized that that doesn't make sense, because the vast majority of these potential customers don't want to pay that much money to then have to spend a lot of time and effort running one of these large size pieces of equipment in-house. Turns out they just really want the parts and components that can be produced by these types of machines. So once we figured that out, we pivoted to this purely on-demand service-based model of using our own machines that we will be designing and building, using those in-house to print parts and components for our customers, with the long-term vision of then building and running an entire nationwide network of micro factories to then also cut down on the shipping time and costs and all the general logistical complexities of shipping large amounts of large size parts and components all the way across the US. Now, even though there are lots of potential markets for us to focus on first, like I mentioned, aerospace, automotive, oil and gas, agriculture, and even the entertainment industry, which we've had a whole lot of interesting conversations with people. The first industry that we plan to focus on will be the autonomous mobile robots industry, specifically printing parts and components for these new generations of construction robots, warehouse robots, security, delivery, all of the new ones that are starting to come out. This industry is perfect for us to focus on because their use cases exactly align with our capabilities of using larger size, high strength plastic components. And these companies are much more open to new manufacturing technologies, unlike some of the more traditional legacy industries like aerospace and automotive that are much slower to adopt new technologies and want them a lot more validated. Definitely love to get to them down the road, but starting off, robots is the way to go. That's pretty good, quick overview of what we're doing, what we're building, where we're planning to go. Sabine, you want to give them a little bit of information, kind of your background, what you've done, and what you do and will be doing in the future?
Sure. Hi, everybody. My name is Sabine. My background is a little bit multifaceted. I started off with physics and fine arts, as well as I had a little bit of biochemistry lab experience dabbled in there. And then I found out that I really loved material science. And so I went to Argentina, where I was raised, and I studied pretty much for, I'm going to say, an extended 3 years to really fall in love and kind of get used to and learn about kind of the supply chain side, as well as, excuse me, the supply chain side, as well as having a little bit more laboratory experience with regards to, again, material science. So I came back and I really couldn't find, for some reason, I really could not find a job. Who knew material science was not as popular as it is today, or I think it is today. And so I got into a little bit of the financial world, but I'm really glad that I met up with Riley in, when was it, Riley? Like 2017?
Yep, going through Founder Institute.
Yeah, going through Founder Institute, great incubator program. And thankfully I was able to, again, renew my passion in material science. And Riley and I have been partnering, I guess, ever since. It's been, as LinkedIn says, 3 years and 7 months.
Yeah, that's been impressive that we've been working away on this that long and finally getting it to where it's really ready to take off and go. Yeah, I figure I'll go over my background real fast. So like I said, have a degree in mechanical engineering. This is actually my second startup. The first one that I was working on was in essentially heavy manufacturing, doing meteorological towers for validating potential locations for wind turbines, as I got very used to saying a long time ago. But it was a whole lot of like hard manufacturing, construction of actual like durable goods, doing lots of prototype work, and got a whole lot of experience with essentially designing things in the morning and then having them built and fabricated by the end of the day and doing it very quickly and cost effectively. Also got a whole lot of experience with CNC equipment, robotics, and all of that experience is what kind of enabled me to see not only on the customer side of what 3D printing, especially when you start talking about larger size capabilities, higher strength materials, of all of the amazing opportunities for that to address a whole lot of market needs, but also seeing how a lot of the options available were seriously lacking in the capabilities, because everything was very slow, very expensive, or very small. And the few things that were large, they were just scaling up essentially desktop machines, which was a really unimpressive way to do that. So after leaving that startup because Congress killed it, that's a whole nother story, had kind of come up with this 3D printer idea and turned my garage into a workshop when I moved down here to Austin and started designing and building the prototype. And now it takes up half of my garage and been cranking away doing stuff in there for a while now. As far as like how the company's been going, our history, figure kind of run through that real fast. So as Sabine said, we met during Founder Institute. We were part of the first Austin cohort, very end of 2017, very beginning of 2018. And that was kind of when this idea and project, because up until then it was pretty much just a project, really turned into a serious company. And we started going after it like very dedicated and full time. We spent the next about a year finishing the prototype, getting it working, starting to kind of do some initial customer work, and then got accepted into Techstars. And that, which if you don't know, Techstars is one of the premier accelerators in the world. It's basically Y Combinator and Techstars are the two big ones. We got a solid chunk of money, went up to Hartford and spent 3 months up there during end of summer. Do what? Oh, yes,
Hartford,
Connecticut. Sorry for people who don't know. Got to skip Texas summer, which that was fun. And so we summered in Connecticut and hung out up there and got to meet a whole lot of really awesome connections. Of that was the reason that we wanted to do not the program in Austin, but one outside of Austin, and especially one that was focused on additive. We got connected to a whole lot of people and networks that we would otherwise not had access to. And that finished in about 2019, 2020, kind of the year that wasn't. So we were just focused on survival mode, doing print jobs when we could, finishing like working on the next generation machine, which is now currently about 90% designed and 90% of the components ready to go. It's basically a big pile of parts in the workshop right now. Unfortunately, don't have enough space or even amps to run it, which is one of the big reasons that we're raising right now, so that we can get out of the garage and get actual pilot facilities set up, finish the last tiny 10% of development on that machine and be able to start replicating it and building more and starting to crank out parts. And that kind of got us to the beginning of this year when we decided to dive in on Wefunder, which so far is going fantastic. This week was really kind of surprising and very exciting at how quickly we went from starting off at about 60 or 70K when we went public, and we're already now almost to 130,000 in just over a week. And it has been awesome having so many new people join the team and believe in what we're doing and believe in our ability to execute and make this a multi-billion-dollar company, which is our whole goal of having an entire new way of doing manufacturing spread across the entire United States, all interconnected, working together so that whenever or wherever somebody needs components or parts produced quickly, they will be able to get those, and they'll be high quality, high strength, and be able to do everything they need. I think that's pretty good kind of update on everything that we've done and been doing. Figure I'll go ahead and answer. We can go ahead and answer the questions that were already put on the Wefunder page that were asked by people, which you can get to those from the Wefunder page, Ask a Question tab. We love answering questions that people have. Want to make sure that everyone has a fully solid understanding of what we're doing. But for anyone that hasn't made their way over there and read through those, figure we'll kind of go through those right now. First question, which was asked by Brett, was, would this be industrial focused only, or would you generate 3D printers that might be used in residential or commercial real estate? Now, this one, when I answered that, I think he was talking about basically 3D printing houses or 3D printing the actual structures, which we've had a lot of people ask this. I mean, we're here in Austin, and Icon is here in Austin too, and they're one of the big players in 3D printing, actually out of concrete and structures. And yeah, Sabine, how many times have we gotten asked if we're printing houses,
Quite,
or can we
quite
print houses?
yeah, quite
Quite.
a few.
Yeah. So this one, the short answer is no, but that's just on the printing the structures. There are a whole lot of really interesting use cases and possibilities for printing the systems that go into the structures. Like one that we just recently saw was a company that is using larger size 3D printing to print the actual HVAC ductwork that goes into buildings. And the whole reason that they're 3D printing these is, one, you can make the actual geometry of it much more efficient just by having it not be boxes and squares and sharp corners and all the standard sheet metal ways of putting things together. I think they were saying that they were seeing about a 10% energy improvement just by having the shapes be much more optimized. It's also being made out of recycled and recyclable materials that you basically just grind it up, melt it back down, and print more stuff out of it. But they're also doing a very interesting thing of being able to deploy it in a way that you can't do with metal, to where they were printing as it went lots of little holes throughout the entire structure. So the entire duct was one big vent, as opposed to having discrete points, like just blasting all the air out of those one areas. So you end up with a much more uniform and efficient system. That is always a possibility. Something like that. You get into also on electrical, furniture, facades, whole lot of really interesting possibilities. But as far as doing like the actual structures themselves, maybe on printing molds for concrete to be cast into for decorative stuff, but we just focus on the high strength plastics because that in and of itself is already a several $100 billion opportunity. And so got a while before I think we'll be stretched for potential ones to go after.
Yeah. I mean, we've also been solicited by enterprise companies, potentially in the future, to, I guess, use our machine, replicate our machines, and keep them in different locations. Remember when we were in Techstars?
Yep. Yeah, we've had. That's one of the things that'll get into which I guess we can go ahead and talk about that right now. That's a good segue into one of the questions that we get all the time, which is one of the ones we're planning to answer anyways, is why aren't we selling machines? We've had a whole lot of people either assume that's what we're doing, ask why we're not doing that, because that's kind of what you would expect. That's where your mind naturally goes when you hear that someone is building these large size things. And it really comes down to that for all of the use cases and potential customers, how the price that you have to sell these larger size machines to make it profitable for us, or like all the other companies that's doing it, it immediately prices out the majority of potential customers, because the machines in this same size range, and not even in the same capability range, because ours are much more capable, or at least will be. You're talking hundreds of thousands of dollars, like starting off at 200-300, easily getting up $600,000-$700,000. That's a massive capital expense and capital investment. And even if you're talking about a service provider that buys other machines made from somebody else and then runs them to then provide the service of producing components and parts, they run into the issue of they have to charge a whole lot more per part to pay for the machine to basically cover that cost. But because we're just do it.
Oh yeah, no, sorry. I think the other thing is that what a lot of people don't realize is that if we were to do that, we would also have to add on a completely different department for engineers or techs to actually go out.
Service, warranty, all of that stuff. Yeah, which that's just a whole headache we have no desire to deal with. It also, selling machines, the amount of like money and energy and engineering and time that goes into developing a machine that anyone can use, but that is also easily and cost effectively manufactured, that is a much higher bar than us just making something to use in-house just for ourselves. So not only just the development process, but then it's going to be much cheaper for us to just build them ourselves. We're thinking that to actually, for us to be able to produce one of these is going to be $50,000 or $60,000 to have it in house. So we're talking, we're going to be getting our machines, which are going to be higher capability, higher performing, larger size, faster, more cost effective, and for a tenth of the price, depending on some other printers comparing to. That means we can pass all of those efficiencies and savings onto the customers we're going to be working with. And more importantly, they don't have to deal with running machines in house. Even the really good, well-developed, large size industrial 3D printers out there are a pain to use. There's setup, there's takedown, there's cool down, there's calibration, there's dialing in, there's maintaining the filament, there's processing the filament, drying, all of these different steps, which unless that's your core competency, that's just taking away time and expertise, and somebody's having to do that who could be doing something else. And that's been kind of the biggest thing that we've heard from people, is that they just don't want to run them. Not only do they want to buy this, but they don't want to run them. Now, it makes sense for certain like really larger size companies if they want to have that expertise in house and have the capital and capability to do that. Awesome. But that's really the big reason that we're not building our own machines, and why we're doing this pure on demand and then distributed service model, because it makes it more efficient, quicker, and more cost effective to all of our potential customers. Let's see, what was another question that was on the, want to get through the ones that were already on the site, because those were some really good ones on there. How do you compare to R3 Printing, a 3D printing company that's been fundraising for a while? So if you don't know, there's a company called R3 that has been very successful in the crowdfunding. They raised a decent amount of money, but they're doing a desktop machine. So it's much smaller. It's, oh yeah, we could fit like dozens of their machines just in our build volume. And that's kind of the first part of it, is that we are an industrial size, industrial scale, industrial intended 3D printing company. So we're not building small prosumer or even consumer-based machines. That's what R3 is doing, which is awesome. If they can make that better and more capable, then all the better. But we are in an entirely different category, entirely different segment, and we're going after entirely different customers in entirely different ways. I just said entirely a whole lot of times there.
Okay, the same thing.
Yeah, but basically, yeah. Sabine, do you have anything on that one?
Leading into that, for some reason, somebody had brought that up to me like last year. And then just kind of like an analogous question, just because it popped up in my head. One of the things that actually two people have asked me now, is that why aren't 3D printing companies just deciding to move from desktop 3D printers and go into larger industrial? Can't everybody do it? Is it like a thing of technology? I don't quite understand. Like, is it because they think that large scale is not worthy of any attention? And so, I think that's probably a really good question.
That's a good one too. Yeah, I think I've gotten that one too. A lot of that one, I think, like this kind of what we've really figured out is that so hardware is hard, and industrial hardware and industrial size hardware is like hard squared. So it just gets a lot more difficult when you start making things bigger, especially if you're going to be manufacturing them to sell them, because they run into a lot of the same problems of, like, the larger the component, the more difficult it usually is to get it manufactured or sourced cost effectively, especially if you're trying to sell lots of them at volume. It also, the 3D printing, its process itself changes and gets a little different. And that's really kind of where our new design comes in, and our like patented new machine design is, that's the whole thing, is of what sets it apart from both smaller size machines and the handful of other larger size kind of near peer competitors is that our design scales up in size without, like, it scales up in size much more efficiently. So we don't have to have really massively sized drive systems and really big heavy machines to kind of keep things from vibrating and shaking all over the place and degrading quality. So we're able to maintain a much higher speed without sacrificing quality for much larger size components. And being able to do that combination is what kind of really is going to let us carve out a pretty substantial chunk of the 3D printing industry that, a lot of people haven't been going after because, one, it's really difficult, and two, I don't think they necessarily realize how many amazing like use cases and possibilities there are there. That's one of the reasons that we are focusing on the autonomous mobile robots, is because that industry didn't really exist much just a few years ago. It's been just in the last few years that we're starting to see delivery drones or robots driving down sidewalks to deliver people's food, or construction robots on construction sites hanging drywall or painting. Do what?
Zipline as well.
Yeah, Zipline out over in Africa and now in North Carolina, using large size delivery drones for medical supplies and things like that. And then you get into, those are all the use cases for like final use parts. You get into the actual assembly of things, being able to do jigs and fixtures and trays to hold everything in the right place, that you can make those very like quickly and cost effectively. And if they break, then it's not an issue. One of the case studies we found was at a Volkswagen plant, in just 1 year, with just small size machines doing just their smaller size parts, was able to save $300,000 or $400,000 over the span of 1 year, printing out like fixtures and tools used in the assembly process, as opposed to ordering them from a third party. Like on one tool, the cost went from $950 each to like $20 each, and the lead time went from almost 2 months to like a week. And that adds up. And that was like, you're talking small little things. When you start being able to do bigger things for larger size assemblies, those benefits just cascade and scale up even more. Let's see, what were some of the other questions that we had on the site?
Has the patent been granted?
Oh, yes. That is, that's a good one. Yes, it has. It got issued on May 4th, which Star Wars Day for the nerds who are in the know of that. Fully issued, fully granted. And we've had protection on that for over 2 years, because we filed our provisional patent back in summer of 2018. So we have been fully covered on that for a long time, and it is done. It's set. It's actually according to our patent attorney, a surprisingly strong patent, which like to hear that. We got all 20 claims with only a handful of extremely minor language changes, and that was it. So yeah, we were very surprised at how quickly and smooth the review process went, to where it was like, can we change this one word, this one word, this one word, and that one? And that was it. And all 20 claims, good to go. So yes, fully issued and ready to go, and have the plaque hanging in my hallway because it's my first one and I'm excited about it. What was...
Let's see here. The next thing is basically, any thoughts on 3D printing with stronger materials than CF nylon, CF, PP, et cetera, as part of your growth and marketing expansion?
Yes, very much so. Yes. Those kind of mid-tier, solid, very capable engineering grade polymers, especially the composite reinforced ones, whether it be carbon fiber or glass filled, all those are just a starting point. Like, that's just what we're planning to be the focus with our kind of low temperature machines. That said, we do think the carbon fiber nylon is going to basically be our bread and butter, because it has compared to anything else out there, it has the best combination of performance, printability, use cases, and the cost of the actual like materials itself. It is really going to be a game changer for a lot of different products and components on how they're manufactured and how they can be manufactured. But we absolutely do want to get into the higher performance, higher capability ones. CF PEC is probably going to be another one we spend a whole lot of time printing, because it's basically the better version of PEEK, which these are high temperature, like super polymers, to where you're comparing them to aluminum parts or using them to replace aluminum parts. Then there's things like PSU and Ultem, which the nice thing about those is those have already been, a lot of those polymers have already been certified for things like aerospace and automotive, which means that as long as we print them and then are able to validate that the strength was right, that means we can start doing prints that can be actually used in aerospace or automotive or these other areas, to where we're not having to then get new materials certified and ready to go. We're using stuff that's already been figured out. We're just manufacturing it in a slightly different way. Those we want to get to kind of as quickly as possible, because there are some fantastic use cases, but that's going to be like step 2, with step 1 being get our kind of lower temperature, still extremely capable machines built, dialed in, running. And then once we've got all that figured out on lower temperature ones, then we can really tackle the crazy super polymers.
Let's see,
what was one of the other ones?
I think that was pretty much it with regards to, and then just asking to talk.
Yeah.
Always.
I lost. Yeah, some of the other really common ones that we get is like why microfactories. We've had a decent number of people asking about like why do this distributed model versus like a centralized facility. A lot of that comes down to one, which this is a really awesome benefit. It's not the main benefit, sustainability. It just, you use less energy, less fuel, and produce less emissions the shorter your products have to travel. So if something is being produced from a common feedstock and it's only being made like in your city, or maybe the city next door, as opposed to the other side of the country or the other side of the planet, that's a massive decrease in the environmental effects of that part. I think Mark Forge did a case study with one of their customers that compared printing components locally versus traditional supply chains like coming from China. And it was a 17.5x decrease in CO2 emissions per part. So that's a really awesome benefit. It's not the main one. It's more so because it just makes logistics and the systems a lot easier. If you're not having to do shipping larger numbers, because ideally we want to get into production, not just prototypes and one-offs, but actually doing hundreds, maybe even low thousands of final use, end use parts and components being sold to our customers that are then using them in their final use products. And when you start talking about the logistics of shipping and moving large amounts of larger size parts, that can get expensive pretty quickly. It also makes it less kind of on demand and more kind of a batch model like traditional manufacturing. We see it being a really good way for companies, especially as they're scaling up or doing a digital warehouse service for spare parts, to where they're not having to store large warehouses of legacy parts. They just have files that we keep ready to go. When they need something, not only do we just print it out just when we need it, but we can print it out as close to where it's needed as possible, because the company may be based in LA, but they may need the spare part in New York. So we can just print it on one of the machines as close to that as possible. So having that distributed, decentralized network offers a whole lot of flexibility It offers a whole lot of supply chain resiliency and resistance. So if there's any like regional issues or disruptions, whether something's happening on the other side of the planet, or if like there's a hurricane in Florida, or there's an earthquake in LA, none of those things will completely disrupt and destroy someone's supply chain because other facilities can pick up the slack and still be able to get things produced and moved around. Oh, got one coming in asking the audience, what are some of the additive options and acceptance barriers / speed bumps that you are seeing, that you're anticipating? One of the biggest ones is just education. That a lot of people who are on the industry side, who are like producing these robots or aircraft or automotive, they just don't know that 3D printing is ready for prime time for a lot of these use cases and can offer some pretty substantial benefits. Another one, which Sabine, I'll let you jump on this, is on the material side, which is starting to be worked on.
Yeah, I think that this is actually prime time, because there are so many phenomenal researchers out there, and even like great materials that have been coming out probably just within the past like 5 years because they saw the trend in 3D printing. But unfortunately, not a lot of people have caught on. And again, if you're in a like lab environment, do you really have that much hands-on experience with like enterprise? Not really, unless you're, your lab TA or the person heading up the entirety of the lab is very well connected. So, or you're using a 3D printing, 3D printers within your university, which often happens. I think that the other thing that kind of leads itself into this too is the other potential like hiccup is that every time we encounter somebody who like asks us how large is large, or they say large format, right? And large format for them means the standard, I guess, large format print volume. Probably how much do you think is like the triple of like a standard or a larger standard desktop?
Hours?
No. In terms of like the standard of like what a large format.
Yeah, double, triple, maybe
Double,
quadruple. Yeah.
so I
Still
think
dozens of size times smaller than what we do.
right. And so I think that we have to come up with, until Riley actually shows, like, here's an example of the print. We actually measure, again, he says, we actually measure in feet rather than inches. It finally clicks, but maybe we have to come up with a different, I guess, a different term, something that can really like differentiate us from what people have in their mind as large format.
Yeah. And I think the last kind of potential speed bump and hiccup that some people have with 3D printing, which is one of the things that we'll be working to address, is consistency, and just making sure that the 100th print is just as good as the 10th print, which is just as good as the first print, so that you have really consistent part quality. This is where we're going to be incorporating things like computer vision and 3D scanning into the machines, as well as some automated back-end systems to keep track of the entire life of that part and how it was printed and all of the factors that went into it, from like the temperature and humidity of the filament down to the actual environment in the printer, and then the post-processing that went onto it, and then testing on both it or kind of sacrificial pieces printed along with it, to make sure that we are tracking and have a really good handle on that kind of quality and repeatability and consistency of the parts. Because I think that's one thing that it's being worked on, and it's getting a lot better. But like with just the general knowledge of it being capable, I don't think a lot of people know that that capability is there and that it's continuously getting better. Let's see. What other questions? Sabine, can you think of any other common ones that we usually have?
I think that the other common one is like, why are you using, like, what exactly, since you are essentially like a 3D printing service bureau, don't people just use, 3D hubs, for example?
Yeah. That is, yeah, that's when we do get quite often. And a lot of that comes down to cost and capability. If you go on to a lot of these service providers and you throw a part in that's over, say, 500 millimeters in any dimension, a lot of times it'll say that's not printable or time for a custom quote. And what that usually means is they're going to break it up into smaller pieces and then glue it together because they can't print it all in one shot. So capability, biggest one right off the bat. Then you run into cost because I've actually priced out some parts that we've printed, and the same part, but just changing material from, say, PLA to a carbon fiber nylon blend, saw the cost go from $550 to almost $4,000. Even though the actual material cost difference that would go into those parts was only about 250 bucks. The reason that that was so much more expensive was because that higher capability part, that CF nylon part, would have likely been printed on a $400,000 to $600,000 machine, which means they're having to charge $20, $25 per hour of runtime just to cover the cost of the machine. We're only going to be charging like $2 or $3 an hour when you actually run it all out. So capabilities that they don't have, much lower cost, especially when you start talking about higher capable materials, and just speed, that we're going to have faster printing machines, higher capability machines, and that we're going to have these facilities ideally closer to our customers. So
And oftentimes consistency, right?
that too. Yeah. Yeah. Especially if you're talking about having to split something up into pieces, consistency goes out the window very fast because then it's a fully custom thing.
Right. And not only that, but oftentimes some service bureaus now some companies don't want the hassle, right, of basically handling several hundred, several thousands machines. So what some companies have, 3D printing service bureaus have done, is that they've hired out, right, a lot of independent either manufacturers or people who take 3D printing extremely serious and make it their entire life. And so they're 3D printing at different locations all throughout the world. And so they put consistency or I guess quality regulations and do checkups for their, I guess, providers. But it's never, again, a printer that is in, for example, Texas is not necessarily, even though it's the same, might very well not print the exact same in Kentucky, right?
Yep.
So that's another thing.
Yeah, all of ours being all connected on the same like back end and network means we'll be able to track all of that much more consistently. Yeah, so just realized we're already at like 10:45. We're at the 45 mark. Yeah, that's kind of the awesome thing is can very easily get run away with talking too much about this. So looks like there was a few other ones that we didn't get to, but I actually have stuff that kind of need to run off. So if you weren't able to get your question answered this time, we're going to be doing these every week. So this week plus 3 more for the next month, every Friday, 10 a.m., giving kind of updates, quick overviews, and then jumping in and answer these questions. Really hope that all of you keep asking more questions so that we can keep engaging, making sure that everyone fully understands what we're doing, what we're building, and all of that awesomeness.
I'll also put up Riley's email as well as my email in the chat. So you guys, if you would like to reach out and ask questions directly, feel free to do that as well.
Yes, we are usually pretty good at responding to that stuff. Hopefully, the spam will be kind when you email, because that has happened sometimes. But all right, thank you everybody who jumped on, listened to us explain what we're doing, talk about our big, huge, awesome vision for the future, and we will see y'all next week. Bye.